Here I have a 10-gram bottle of deuterium oxide, otherwise known as heavy water. It is expensive, as this little bottle set me back about $50. Normal water contains 2 hydrogen atoms and 1 oxygen atom. However, heavy water or deuterium oxide contains 2 atoms of deuterium, which is an isotope of hydrogen, and a normal oxygen atom. Normal hydrogen contains 1 proton and 1 electron. However, deuterium is a stable isotope of hydrogen that contains 1 proton, 1 neutron in its nucleus, and the electron. This makes the isotope of hydrogen heavier. D2O, or deuterium oxide, is the chemical formula. It is not radioactive. Its density is about 1.107 grams per cubic milliliter, whereas normal water is 1 gram per cubic milliliter. The density of deuterium oxide is slightly heavier instead of a far greater density is due to the fact that 90% of the water molecule mass is taken up by the oxygen atom. The melting point of heavy water or deuterium oxide is 3.82 degrees Celsius or 38.88 degrees Fahrenheit. Normal water, however, its melting point is 0 degrees Celsius and 32 degrees Fahrenheit. Deuterium oxide's boiling point is 101.4 degrees Celsius or 214.5 degrees Fahrenheit. Normal water boil point is 100 degrees Celsius or 212 degrees Fahrenheit. Also, if you notice that in large quantities, normal water has a slight blue color to it, as this is noticeable on tropical beaches and in swimming pools, due to the white background. However, this is not the case with heavy water. Heavy water is colorless no matter the quantity. The white-colored pool floor and white wall would appear white if the pool was filled with heavy water. U.S. scientist Harold Urey discovered deuterium in 1931 and was later able to concentrate it in water. Gilbert Newton Lewis isolated the first sample of pure heavy water by electrolysis in 1933. There are other types of heavy water, such as tritium oxide, which is radioactive, as the nucleus of the hydrogen isotope of tritium contains 2 neutrons, 1 proton, with the electron in its outer shell. Deuterium oxide is primarily used in nuclear energy. Heavy water also negatively affects cells of multicellular organisms. However, certain bacteria can live in a pure heavy water environment. Chemical bond energy depends on the reduced mass of the nucleus electron system of hydrogen. To perform their tasks, enzymes rely on the finely tuned networks of hydrogen bonds, as hydrogen bond with deuterium is slightly stronger than one involving ordinary hydrogen. Some normal reactions in cells are disrupted, causing them to either die or inhibit healthy cell division in heavy water. Plants stop growing and seeds do not germinate when given only heavy water, because heavy water stops cell division. Also, it is not a good idea to consume heavy water on a daily basis. It would take large amounts of consumption where the body's water is replaced with anywhere from 25 to 50% of deuterium oxide or heavy water in order to do any damage to the body. The human body alone already contains a small amount of heavy water from natural means, probably about anywhere from 3 to 5 grams. Even a small amount, if consumed, won't cause any harm. But large amounts on a daily basis, enough to replace the regular water inside, may kill a person. About 1 out of 6,400 regular water molecules contain naturally formed heavy water. On a daily basis, a glass of normal water contains about 0.00000132225% of deuterium oxide. So it's very, very small. Now, onward to some experiments. Okay, here's a piece of deuterium oxide, which is heavy water ice. So what we're going to do is we're going to put that in normal water. What should happen, it should sink. All right, there we go. Pick it up, put it right down in there. There you go, it's sinking. There you go, you can just see it in there. There you go, the heavy ice is sinking to the bottom, deuterium oxide. And it's not melting because this water is around 33 degrees Fahrenheit. And the melting point of the heavy water ice is 38.8 degrees Fahrenheit. Okay, what I have here is a cap full of normal water. We're going to do a sodium water reaction and a sodium deuterium oxide reaction. So we're going to do both. So first we're going to do normal water. So we're just going to put a little bit of water or a little bit of sodium in there for a normal reaction with water. And then after that we're going to pour deuterium oxide in there and see a reaction as well. Here's a little piece of sodium. Cut that up a little bit. Okay, are we ready? Yeah. Okay, I got about a couple milliliters of heavy water in there. Let's check out the sodium reaction. Okay, the sodium doesn't react as much with heavy water as it does with normal water. Normal water. Okay.